So welcome to this session as part of the Data Infrastructure Forum. Today we will be covering data platform resilience and how you can maximise your data platform availability. So my name is Martin Lambert and I'm part of the Database Cloud Exadata Platform product management team. Your data platform is at the heart of any workload or application your business requires, whether that be from gene therapy, COVID-19 testing capabilities, through to fraud detection and the service you provide to customers. As we have already seen, workloads for business requirements can lead to fragmented single-purpose platforms. Having a robust, resilient, consolidated data platform servicing your business requirements is essential to achieving a converged architecture that can transform your business. And how this data platform manifests itself to your customers can take many forms, be that from a ride-sharing platform, such as we see with the Grab in Asia Pacific, which is expanding to other areas utilising this platform, through to the hospitality industry, an example being the Trace Together application in Singapore. Valid vaccinations can now be tracked through the application to allow customers safe access to hospitality venues. Resilience within the data platform allows for success even in these ever-changing markets, where there is a deluge of data to contend with. Underpinning these data platforms of digital transformation are 8 key architectural tenets. High availability along with scale and performance to provide a data platform that can provide answers to the most resource-intensive queries. Accessing of data from a variety of sources, which needs to be performed in a secure and reliable manner, through to the governance of the data residing on the platform. So the combination of these architectural tenets is what forms the foundation for the Oracle Engineered Systems line of products. At Oracle, we build our technology so that it's designed to work together from the start. That gives us a unique ability to offer customers a complete hardware and software stack, from applications through to middleware and databases, all the way down into the storages and the servers. We offer all these both on-premises and in the cloud as well. So each of the layers and all the products within the layers have been designed and engineered to work together according to open standards. And because we design it to work together, we're able to optimize performance. So this complete approach lets us build greater reliability and security, and we can achieve this a lot faster and more reliable than from parts with different vendors. And because we have management tools that run through every layer, it's also much easier to manage the stack and upgrade it over time. So the net result is that our customers spend a lot less time and money on routine tasks and a lot more on strategic projects. So by engineering every layer of the stack, Oracle provides an integration across the different dimensions. Within each layer of the Oracle technology stack, all components are engineered to work together, either individually or as part of a product family or suite. So this ensures that all products in every product family and every product suite can interoperate with each other. So Oracle integrates between the layers of the technology stack. So this involves testing and certifying every layer to work with every other layer, from the applications down to the servers and storage. And because Oracle owns the entire technology stack and because Oracle engineering teams work closely together, Oracle can optimize the entire stack's best-of-breed components for performance, scalability, security, business intelligence, reliance, and manageability, and can share these technology advances throughout the whole stack. So the Exadata vision on which this is based follows a simple mantra. It's a platform for all database workloads, in the cloud and on-premises. It's Oracle's database acceleration platform, a combination of vertically integrated stack that runs the Oracle database in the most optimal way. So this vertical integration is in the form of database hardware, which is pre-configured database servers, storage servers, and the networking connecting them. On top of this, Oracle delivers software with its storage server software, allowing processing of SQL queries at the storage tier. So allowing for high density consolidation of mixed workloads with segregation of input-output requests, through to the latest innovations in database functionality with the releases of Oracle 21c database. So then this has an automation layer wrapped around the hardware and software capabilities to optimize the configuration software upgrades, and the performance tuning. So the Exadata Platform is built for resilience. The core of the Exadata Platform can be broken down into three main areas. So the database servers, so these are running the Oracle database engines. The storage servers, which houses the data and provides the result sets to the database servers. And then lastly, the connectivity between the database servers and storage servers, provided by the network switches. Redundancy to achieve this resilience can be found in the database servers, so they are active, and they're configured with Oracle's Real Application Clusters technology. Hot swappable and redundant power distribution units, and we have the mirroring of data across all of the storage servers. So redundant network connections and switches, and with all three of these categories, we have high availability software and firmware throughout the whole stack. So Oracle has for many years been talking about its maximum availability architecture. How do we get from a single instance database with a single point of failure to a highly resilient data platform, offering 5 nines service level agreements? This is approximately 26 seconds a month of downtime or unavailability. So Oracle's maximum availability architecture is a series of reference architectures that, if followed, can provide organizations with these types of service levels. So the journey starts with a series of architectures that we will call bronze, silver, gold, and platinum. Before we take a look at these architectures, there is a requirement that organizations need to take into consideration when determining which architecture to implement. Determining the recovery point objective, or RPO, determines how much data loss can my organization tolerate. Recovery time objective, or RTO, determines how quickly my databases and applications need to be brought back online. There are different types of downtime depending on which type, and there are different technologies that can help achieving the RTO or RPO. So we can have planned maintenance, where we have database instance restarts. We can have grid infrastructure or database patching. We have operating system patching. We have hardware changes that can all be part of the planned maintenance. Then we might have database upgrade scenarios where the database normally may require some downtime in order to update the dictionary to the new version. And this upgrade can be rolling or non-rolling. And normally with planned maintenance, we have no downtime via the rolling upgrades. So then we have recoverable failures with things like node crashes or instance or power failures. These physical failures that can be recovered quickly. And then we have unrecoverable failures such as site loss or disasters. So depending on my RPO and RTO will determine the architecture required to implement a resilient data platform. So single instance itself already contains good protection from some failures. It's ACID compliant, the redo log protection is intrinsic and robust and gives basic protection. Online reorganization allows online table redefinition without impact for the application. Runaway resource management protects noisy neighbours, runaway statements, and host resource saturation, such as instance caging. Building on the bronze, we're now going to reference the silver MAA level. So Real Application Clusters gives protection against node failures. This enables rolling patches, service draining, and zero downtime planned maintenance. So we can use application continuity to protect transactions from failures, allowing safe transaction replay using JDBC replay drivers and Transaction Guard. Engineered systems give additional features for data protection, problem detection, and resolution. Building out the silver reference architecture gets us to gold. With Active Data Guard, the optimal solution to achieve protection from unrecoverable failures, such as corruptions, site failures, and physical loss of database. It also enables unique features that like rolling upgrades and scale out for read-only workloads. Then the top of the line 99.999 or 5 nines availability is the Platinum maximum availability reference architecture. So with Golden Gate, this allows us to have logical replication among primaries, making it possible to have an active-active architectures across data centers and regions. So this allows new scenarios of online upgrades and read-write scale-out. We have edition-based redefinition, giving developers the possibility to upgrade their application online. Different versions of the application can use different editions of such views and packages, allowing their concurrent application. Application can then be redeployed in the application server farm in a rolling fashion. So lastly, we have sharding. So the sharding architecture allows linear horizontal scale out of the database by dividing the data into shards. So local data can be accessed with direct access to the shards. So this architecture is the hardest to achieve and is used success by many customers to achieve 5 nines SLA for their mission critical workloads. So deployment of the maximum availability architectures can be performed on the resilient engineered systems platform Exadata. So the Exadata platform can be deployed to suit the customer's choice of deployment. Still want to do your deployment of your databases in your data center? Not ready yet to move your application to the cloud? We give you the on-premises capability. I'm happy to move my database fully to the cloud. Exadata Cloud Service is your deployment of choice. I want to move to cloud, but I have data sovereignty concerns or latency requirements between my application and database tiers. Exadata Cloud at Customer is your preferred deployment choice. As a customer, the choice is yours. Exadata Cloud at Customer can support the top reliance architecture of Platinum. This provides the highest level of enhanced protection for the customer. Multiple sites running primary and disaster recovery with local standbys in a synchronous data guard replication mode. Exadata Cloud Service, the same type of deployment except now it's in the cloud. The performance characteristics, the resilience achieved in your Exadata Cloud at Customer can be seen in the Exadata Cloud Service. De-risking your deployments by having the same resilient architectures no matter your choice. And these data platforms are implemented across thousands of customer sites and Oracle's own cloud. So we're giving you a globalized standard of deployment that learns from the scalability of a telco customer, so the availability requirements of a banking company, to the security of a government organization. The same resilient data platform is deployed and the customers benefit from what we call the community effect of the Exadata Resilient Platform. So Oracle's commitment to the Exadata platform is increasing. From our Oracle SaaS applications being deployed on tens of thousands of Exadata systems in Oracle's public cloud, to the Oracle Exadata Cloud at Customer being able to run both the Oracle database and Oracle's autonomous database in your data center behind your firewall. So Oracle's commitment to the Exadata platform is ongoing, no matter whether it is in Oracle's cloud, on-premises in your data center, or in the hybrid mode within the cloud and your data center as Oracle's Cloud at Customer. So this highly resilient platform can be purchased in any one of these forms, and it's totally up to the customer how these platforms are deployed. So thank you for attending this session on data platform resilience, maximizing availability. Have a nice day.